Hi boys, I learned a really important lesson the other day when I was trying to record my class video, and that is to always make sure that you press record properly. So I'm remaking this video because the one I made in class the other day was not actually recording. So this video is the first of two videos about the types of triangles. The second one is a video of my class lesson. So in this video, I'm going to go through the properties of equilateral triangles and isosceles triangles, and I'm going to show you how to construct some of those. So I'll just flip my camera around so you can see my page. All right, so the first thing to always remember when you're thinking about triangles is this really important fact up here, okay? So the angle sum of all triangles, no matter what kind of triangle they are, will always equal 180 degrees. And so what that actually means, if you were to draw a triangle and you were to measure each of the three internal angles inside, they would always equal 180 degrees, okay? So the only thing to think about there that might be a bit off is if you draw and measure them and you are like 1 degree out in one of the measurements, and you might get like 179 degrees or something, but that's just a measurement error, okay? So if you come across that, that's what's happened. All right, so firstly, thank you to all the boys whose equipment I have stolen this morning. Jake, and this is also Archie's maths book, and Billy's pencil. Thanks guys, really appreciate it. All right, so let's say that you're asked to draw an equilateral triangle. So we're talking with an equilateral triangle, 3 sides of equal length, whatever that might be, and 3 angles are equal. And because we know this fact here, that means every angle in an equilateral triangle must be 60, okay, because 3 lots of 60 are 180. Okay, so let's say that you're going to draw a triangle with a base of 5 centimeters. Okay, so I'm just using a regular ruler for this. All right, the first thing you need to do is to measure your angles of 60 on one side and 60 on the other. So it doesn't matter which side you start on, up this side or this side, and then from there you can construct your triangle. So you've got to start somewhere. So your base is 5 centimeters in this case. All right, remembering with our protractor, we're looking at putting our crosshair on the edge of the line, okay, and then making sure our line of our protractor matches the line that we've drawn. So that's no good. Even though the crosshair might be in the right place, you've got to make sure that line is flush there as well. Okay, so the second thing to remember is that when you are drawing an angle, you've got to go from the set of numbers, be it the inside set or the outside set, that starts with 0. And that's going to depend on which side you're using. So because I have put my protractor on the left-hand side, I'm going to use this set here because it starts at 0. If I was to do it over this side, okay, I'd be using the outside set because that's where it starts from 0. All right, so just double check that before you start. And I'm going to go up to 60, 0, 10, 20, 30, 40, 60, okay. I'm going to put a little dot there, all right, and then I'm going to connect my line. Now, because this is an equilateral triangle and all my sides must be equal, I'm just going to draw it lightly, okay, and then I'm going to make sure I measure 5 centimeters, okay, which just by chance happens to be where I've already put my dot. Sometimes it won't be that exact place, so always double check. Now, this is another quick way you can just finish it off by doing this, okay, because I know that I've already measured my 60 degrees here, these will be 60 as well, okay. It's always good to double check. Oh, so hard to pick up off the desk, those protractors, okay. So I'm a little bit off, so that might be because yeah, there we go. I've made my line a little bit too long on one side by 1 millimeter. Okay, so 60 degrees there. And then if you go to measure an angle that's not sort of flat on your page, you can rotate your protractor around like this, so long as the line, the corner in the line is in the right place of your protractor. Cool, and I've got 60 degrees there as well. Okay, so I've gone from 0 up to 60. All right, so that's an equilateral triangle, 60 degrees on each side, and then each length is the same, okay? In my case, 5 centimeters, but you could definitely have it longer or shorter as long as they are all the same. Okay, cool. Let's go down to our isosceles triangle. So remembering again that our angle sum is always of a triangle is always equal to 180 degrees. That's a really important fact to remember there. Okay, so just a little background. Isosceles comes from the Greek language meaning equal legs, and that makes sense with an isosceles triangle because we've got 2 sides of equal length, and the third would be a different length entirely, shorter or longer, and that means that 2 angles are equal as well, and the third angle might be again smaller or bigger depending on how big these 2 are. So when we're talking about legs, we're talking about like a person, not a 4-legged creature. Don't get confused by that. Okay, so these can be a variety of different shapes. An equilateral triangle is always going to look pretty much the same. It might be bigger in size or smaller, but the angles are the same. So it's like really sometimes quite easy to tell that it's an equilateral triangle. Okay. An isosceles triangle can be like short at the bottom and really tall like this, or you can have like a really fat one, okay, like this, and like everything in between. Okay, so just be aware of that. All right, so let's say we're going to start with, make some more room on my desk. Let's say we're going to start with like, I don't know, let's go 4 centimeters down the bottom there. So 4 centimeters with my line. Okay, so let's go with angles of 40 degrees, okay? Now, when you're looking at an isosceles triangle, 2 of those are going to be the same, okay? So we're looking at the 2 that are probably going to be along the bottom of the baseline. Remember that triangles can be orientated different ways, like this is still an isosceles triangle even though it's twirled around, but most of the time you'll see them this way. Okay, so again, same process as what we did with our equilateral triangle. Okay, so I'm going to go crosshair in the right place, line flush along the bottom with this one, and then I'm going to go from my set of numbers that starts with 0, 0, 10, 20, 30, 40, okay, and put a little dot there. All right, I'm going to then draw this line sort of along and past my dot, okay, just lightly. Alrighty. Now I'm going to go 40, and that's 40 degrees. That's just an angle that I've plucked out of the air for today's example. Okay, so same deal, I'm going to do the same on the other side. Okay, crosshair, line, whoops, flush. And then my set of 0, my set of numbers that starts with 0 is the outside set on this side, so 0, 10, 20, 30, 40. A little dot there. Okay, and then I'm going to connect that up. Awesome. Okay, so that's 40 degrees there as well. Very cool. Okay, so what I would then do just to neaten it up is I'd just get rid of these parts here. Okay, if you left them there, like if you really push for a time in an exam or whatever, there's no harm in leaving it there. You won't lose marks for that. Not for me anyway. But yeah, just to show you the full example today. Okay. Oh, that's all fuzzy. Wake up camera. There we go. Great. All right. Now, when I think about this fact here, okay, if I know that inside my 3 angles have to equal 180 degrees, and I have 2 that are 40, so 40 and 80, that means that this one has to be whatever else brings my total up to 180. So if these are 80 and I need to get to 180, this is going to be 100 degrees. Okay, and that fits our fact with isosceles triangle that 2 angles are equal and the third is a different size. Okay, so let's check that. Well, I hope I'm right. This could be really embarrassing if I'm not. Okay, so yeah. As I showed you before, you can rotate your protractor so long as you've got your crosshair in the right place and your line flush here. So I'm going to go from a 0 all the way up All right. And I've got it to 100 here, okay, because that line goes through there. All right, so that's really cool. I've got my two angles the same and third different, and so we'll just double check the measurements of the sides. So this is 2.5. And hopefully this will be 2.5 too. Nailed it. Awesome. Okay, so these numbers here that I've got that I chose for today, the 40 degrees and the 4 centimeters, I've just chosen those today for examples only, okay? So 2 angles equal and the third a different size, and 2 sides equal and the third a different size as well. All right, cool.